Okay, let's look at number 11. Again, we are still finding x. These two triangles are similar, so we're given side lengths, so we know that their sides are proportional. So I'm going to set up a proportion to solve. So I'm going to use FR, which is 8, over its corresponding side. If I look up here, FR goes with TR. TR is 5x plus 5. Equals, since I went with this triangle first, I gotta go with it first again, so 10 over 50. Okay, I'm going to cross multiply, and when I multiply this 10, I'm going to distribute it, so I get 50x plus 50 equals 400. Subtract the 50 over. 50x equals 350. So that means that x is going to equal 7. Okay, looking at 12, proportional sides. So I'm going to say 42 over TV. TV goes with FV, which is 28, equals 42 over 10x minus 2. So distribute the 42 to this expression, and we are going to get 420x minus 84 equals 1,176. So we'll add the 84 over. So get 420x equals 1176 plus 84, 1,260, and divide by the 420. 1260 divided by 420. X equals 3. Okay, on 13, we'll do the same thing. My sides are proportional. So I've got two triangles. I got the smaller one, AEB, then I have the larger one, GEF. Okay, so it doesn't matter if you go from the big to small or small to big. Does not matter. I'm going to start with the small, 2x minus 14. Its corresponding side is the big line all the way, which is 66. Equals, still from the small, 10 over the whole thing, 55. Okay, I'm going to distribute, and 55 times 2 gives me 110x minus 55 times 14, 770, and that's going to equal 66 times 10, 660. We're going to add the 770 over. 110x is going to equal 70 plus 660, 1,430. Divide by the 110. And x is going to be 13. And then 14, same thing. Doesn't matter which triangle you start with, what side you start with. I'm going to do UV, 60. UV goes with FV, which is x minus 5, equals 120 over 12. Cross multiply, that's going to give me 120x minus 120 times 5 minus 600 is going to equal 60 times 12 is 720. Add this 600 over. We'll get 120 equals 1,320. Divide by 120. and 1320 divided by 120, x equals 11. Okay, 15. Still the same thing. They're similar, so sides are proportional. So we're going to keep doing the same thing. Let's do JL, which is 5. JL is 5 over JL corresponds with UW, which is 50, equals 6 over 5x. So cross multiplying, we're going to get 25x equals 300. Divide by 25. And 300 divided by 25 is 12. X equals 12. Okay, on 16, let's see, proportion again, since they're similar, VJ is 40. VJ goes with LJ. LJ is 64. Equals 11 plus 6x over 104. Okay, we're going to cross multiply and we're going to distribute. So 64 times 11 is 704 plus 64 times 6 is 384x equals 104 times 40, 4,160. Subtract this 704 over. I get 384x equals 3,456. Divide by 384. And x equals 9. Okay, on 17 and 18, again, determine if each transformation would result in similar figures. If so, state the scale factor. In order for them to give you similar figures, it has to have the same ratio going from side to side, or here from pretty much point to point. Okay, so going from A to J, if you look how they go from -8 to -4, and then 2 to 1, they multiplied by 2. So they did times 2 here. So they have to multiply by the same thing all the way through. So if you look here at B to K, because they are corresponding, -4 times 2 is not -2. Okay, so that does not work. Let me back up right there. I said the wrong thing. I meant to say that if you went from, J to A, you multiply by 2. So now let's look going from K to B. I went from -2 times 2 is -4. 4 times 2 6 though? That is not true. All these other ones, 3 times 2 is 6, -3 times 2 is -6. That one would have worked. And 5 times 2 is 10. That one would have worked. But they all have to work. So these are not similar, because of that one number there that wasn't multiplied by 2. So let's look at 18. Okay, do we have the same ratio going all the way? Well, it's really hard to see what this is, so all I really got to do is put the numbers over each other and see if I get the same thing. So here I get pretty much 3 over 2. If I do these, 6 over 4, which equals 3 over 2 if you reduce it. Here I'm going to get 9 over 6. If I reduce that, 3 goes into both of them, 3 over 2. And then if I do 6 over 4, I've already done it over here, that's 3 over 2. So we're good so far. We're getting the same ratio with each set of numbers I'm putting over each other. C to L, 3 over 2. That checks out. 3 over 2, that checks out. Here, 12 over 8, let's simplify it. 4 goes into 12 3 times, and 4 goes into 8 2, so we get it there. And let's try 15 over 10. 5 goes into both of those. That is 3 over 2, so that checks out. These are similar. And now we are going, if we're going from A, B, C, D to J, K, L, M. If so, what is the scale factor? The scale factor, okay, looking at the scale factor, we have to be very careful looking at the scale factor. If we're going from A, B, C, D to J, K, L, M, if you look, what's happening to the numbers? They're getting smaller, which means we're going from a bigger image to a smaller image. And if we're getting smaller, that means that our scale factor is less than 1. Well, 3 over 2 is not less than 1. So in order to find my scale factor, all I have to do is flip that fraction over, which becomes 2 over 3, and that is smaller than 1. On these last two problems, 19 and 20, with the word problems, you have to draw a picture first. We have two things going on. You have a tree that's 24 feet tall, and it casts a shadow 12 feet long. So I'm going to draw my triangle. I've got this tree here. A shadow is cast on the ground. So my tree here, the height of it is 24. Let's see if I can put that in a different color. 24. Its shadow is 12. Now this is not drawn to scale. And so it's going to make a triangle here from the top of the tree to the ground. Okay. Then we have Brad. Okay. Brad is standing here. Okay. He cast a shadow. Okay. And we have his height here. His height is 6 feet. And how long is the shadow? So that's going to be X. Again, he forms a triangle. These triangles are definitely similar because Brad's definitely not as tall as the tree. So how are we going to find X? We're going to set up a proportion. 24 over 6 equals 12 over X. So 24X is going to equal 72. We're going to divide by 24. And that gives us that Brad's shadow. If you divide, X is 3, so his shadow is 3 feet. Okay, and number 20. Again, word problem, two things going on, so we're going to set up a picture. We have a flagpole that is 40 feet. So here's my flagpole with my flag waving on it. It is 40 feet, and it casts a shadow. The shadow's always on the ground. So I've got a 40-foot flagpole. It casts a shadow that's 25 feet. And it makes a triangle with the ground. Find the shadow cast by a building, a nearby building that's 200 feet tall. Okay, so here's my nearby building. And we want to know its shadow. My building here is 200 feet. And my shadow is going to be X that I'm trying to find. This building, again, makes a triangle. So, similar triangle, so we're going to set up a proportion. So, corresponding sides, 40 over 200 equals 25 over X. So, I'm going to get 40X. That equals 5,000. I'm going to divide by 40 on both sides. And so the building shadow is 125 feet long. Okay, make sure you study over these notes. You go back and rework problems, and good luck on your test Friday. Have a great Thanksgiving break.